So today we're going to learn how to find something called percent composition, which is just the relative amounts of elements in a compound based off their mass. So what I mean by that, let's say we're looking at the compound magnesium sulfate, like from our warm-up. We would just want to know, well, what percent of that is magnesium, what percent of that is sulfur, what percent of that is oxygen. Okay. And so the way we find that is using this equation at the bottom of the slide. Okay. So I know this just looks like a picture, but this is the equation we use. Write this equation down. Okay. So how we find percent composition, we take the mass of the element we're interested in, and we divide it by the mass of the entire compound, and then we'll multiply by 100% to turn it into a percent. Okay, so for our first example, we have an 8.20 gram piece of magnesium, and it combines with 5.40 grams of oxygen. What's the percent composition of this compound? Okay. So what percent composition is asking is just what percent of this compound is the magnesium, and then what percent is the oxygen. Okay. And the reason is, if you just see numbers, sometimes that's not as helpful. Like, what do numbers mean? So percents help us just kind of visualize it better. So the first thing we have to do is get the total mass. All right, so total mass, how much magnesium was used in this compound? Okay, so 8.20 grams for magnesium. How much oxygen was used? Perfect. So then if we just add them up, what's the total? Good. Okay, so our total mass is 13.60 grams. And then now for percent composition, we're going to find it for each element. Okay. It doesn't matter which one you start with. I typically just start with the element that's listed first. Okay. So we're going to start with magnesium. So we're going to take the mass of magnesium and divide it by the total mass. Okay. So what's the mass of magnesium used? 8.20. Okay. So we used 8.20 grams. Bless you. And we're going to divide it by the total mass, which is? Okay, 13.60 grams. So if I were you, I would divide those first. So 8.20 divided by 13.60. Hit equal in your calculator. And then you'll multiply it by 100%. Who has a number? 60.29. Okay, nod your head if you agree. Good. Okay, our unit is percent in magnesium. Okay. And then what's the other element in this compound? Okay, oxygen. So now we're going to do the same thing for oxygen. This time we're taking the mass of oxygen divided by the total mass. So what's the mass of oxygen? 5.40. Okay, so we have 5.40 grams divided by the total, which is? 13.60 grams. Divide those and get an answer, then go ahead and multiply it by 100%. And then all of you, make sure you're dividing these on your own. Like, make sure you know how to get the correct answer on your calculator, and you're not just relying on your neighbor. And then if anyone has a number, go ahead and say it out loud. 39.70. What's the next digit? Should it round up to 71? Okay. Okay, so for these percent composition problems, since there were two elements in this compound, you have two answers. Okay, so it's 60.29% magnesium, 39.71% oxygen. Okay, and then what can you do to check your numbers? Thank you. How do you know if they're correct or not? Add them together, and what should they add up to? 100. Okay, so if you add your two numbers, they need to add up to 100. Now, if they add up to like 99.9, is that close enough? Yes. What if it's just 99? Probably not. Okay, this time we're going to calculate the percent composition of propane, which is C3H8. Okay. So this problem's already different. Notice how this one isn't giving you any numbers. Okay. Do you all see the difference between this one and the previous one? Yeah. Okay, so if numbers aren't given, we're going to use the masses on the periodic table. So the first thing we're going to do, we're still going to find the total mass. So we need to find the total mass of C3H8. Okay. How many carbons are in propane? 3. And then what's the mass of carbon? Okay. And then how many hydrogens are in propane? 8. And then use your paper periodic table for the mass, so we all have the same number of decimals. What's the mass of hydrogen? Okay, 1.01. So if you add those together, what's the total mass of propane? Okay, we're getting 44.11? Okay. It's grams per mole, but I'm just going to use grams for right now. Okay, so then how many different elements make up propane? 2. How can you tell it's only 2?
Only 2 capital letters.
Okay, only 2 capital letters. So by finding the percent composition of propane, it's percent carbon and percent hydrogen. And it doesn't matter which one you start with. I just do the first one. So to find carbon, we're going to take the mass of carbon divided by the total mass. So when we take the mass of carbon, how many times do you have to use its mass?
3.
3, because there's 3 carbons. Okay, so we'll take 3 times 12.01. And then what are we going to divide that by?
44.11.
Okay, that total mass of that 44.11. Okay. So if I were you, I would divide this first. So hit equals, get an answer. And then once you have an answer, you'll multiply it by 100. So then all of you should be entering this. So make sure you know how to enter it. Don't just rely on your neighbor to do it for you. And then if you have a number, someone go ahead and say it out loud. 81.68?
Yeah.
Thank you. Do y'all agree with 81.68? Okay. So now what's the next step? Okay, same thing for hydrogen. How many times are you going to use hydrogen's mass? Okay, so 8 times. And then what are you going to divide that by?
44.11.
Okay, again, that total. So again, I would divide this, get your answer, and then multiply that answer by 100. All right, and if someone has an answer, go ahead and say that answer out loud. 18.32. Do y'all agree with 18.32%? Okay. And then what do you do to check your numbers? Add them. What do they need to add up to? Okay. Really, really close to 100. Okay. So now this question goes right along with the previous one. So now we're going to calculate the mass of carbon in an 82.0 gram sample of propane. Okay. So let's say we have 82 grams of propane. Well, how many grams of that is carbon? Okay. So this one goes off of the previous one. So what percent of propane is carbon? Okay. So we know propane is 81.68% carbon. So then if there's 82 grams of propane, what percentage of that is carbon? The same number, right? So it's still 81.68. Okay. So we just need to figure out what's 81.68% of 82. So the way I solve these, I take my percent and I convert it to decimal form. Okay, so you can write yourself like a little note. Convert it to decimal form. And how do you convert a percentage into a decimal?
Divide by 100.
Okay, so you can divide by 100 or
Move the decimal point.
good. Or you can move the decimal point how many places in which direction?
2 to left.
Okay, or I'm just going to say 2 to the left. Okay, so then what does 81.68% become? Okay, so it becomes 0.8168. Okay. So then now all we have to do is take our sample of 82.0 grams and multiply it by 0.8168. All right, and then what do we end up getting? $66.98. Okay. Do y'all agree? Okay. And what's our unit for this? Like grams of carbon. Okay, so now we're going to find the percent composition of KMNO4. This one doesn't give you numbers, so what numbers do you use? Okay, periodic table. So the first step is to find the molar mass of the potassium permanganate. Okay, so I'm going to pause. I'm going to walk around, so if you need help, call me over. I'll help you find the molar mass of KMNO4, but I want everyone to try this on their own. Okay, what are we getting for a molar mass for KMNO4? 158.04. Do y'all agree? Good. Okay, so now we want the percent composition of all of the elements. How many elements are in this compound? 3. How can you tell? Okay, the capital letters. Okay, far table. Okay, so we have potassium, we have manganese, then we have oxygen. Okay, so now that just means we're finding the percent of each. Doesn't matter which order. I'm just going to go in order of how they're listed. So I'm going to start with potassium. Okay, what is the mass of potassium in this compound? Okay, so 39.10 grams. And what are you going to divide that by? Okay, good. The 158.04. Okay. Get your answer and then multiply it by 100. What are we getting for an answer? $24.74. Okay. Not if you agree. Good. Okay. Our next element is the manganese. What's the mass of manganese?
4.94.
Okay. 54.94 grams. And what do we divide that by? Okay, so divide those, then multiply by 100. What are we getting for an answer for this one? Well, one of you say that again. 34.76. Thank you. 34.76. Okay, and then our last element is oxygen. What's the mass of oxygen in this compound?
16.00. Times 4.
Okay, good. 16.00 times 4, or what does that equal to? 464. Whichever way you write it is fine. And then what are you going to divide it by? What number do we divide by?
158.04.
Okay, 158.04. Okay, so then we'll divide, get an answer, and then multiply by 100. What do you get for your percent oxygen? 40.5% oxygen. Okay, so if we add them up, they equal 100, so we're feeling pretty confident. Good. Okay, so our last practice problem for the day, how much iron can be recovered from 25 grams of iron 3 oxide? Yeah, what? Okay, so we have this 25.0 gram, think like this chunk of iron 3 oxide. Okay. Well, how much iron can we actually get from that sample? Okay. So first, we have to figure out the percent of iron. Okay, so what percentage of iron 3 oxide is actually iron? Okay. So we need to still know the total mass of Fe2O3. Okay. So go ahead and add up the molar mass of Fe2O3. Does anyone have an answer?
17.49 grams.
No, just of the molar mass of Fe2O3. Thank you. 159.7 grams. Okay, so then now we need to know the percent of which element? Okay, iron. So what's the mass of iron in this compound?
55.85.
Times what number?
2.
2. Okay, so there's 2 irons in the compound, so you have to multiply by 2. And then what number are you going to divide it by?
159.7.
Good. Okay, so what are we getting for the percent of iron? 69.94% iron. Do y'all agree with that? Okay. So now we know in this compound, 69.94% of it is going to be iron. So now can we calculate iron in that 25 gram sample? Okay. What do we do with this 69.94%? Okay. Divide it by 100. So what does that become? Okay, so it's going to become 0.6994. So then now we can take our 25 gram sample and multiply it by 0.6994. And then when we do that, now what do we get for the answer? Okay, 17.49, round it, so it's only 3 sig figs. Good. 17.5 grams of iron.